Hello everyone. We'll be dealing with trigonometrical functions. You all have studied that when you compare the two ratios of the sides of the triangle, right angle triangle, for a fixed angle, the ratio will always be constant. The ratio part has been discussed in the 10th class. Now what we see here is the ratio is meant for that angle theta, which is a part of a right angle triangle. Hence, it can vary from 0 to 90 degree. Now, what if the angle is greater than 90 degree? So, to get the ratios for angles greater than 90 degree, we need to redefine the three elements of this triangle. That is perpendicular, base, and the angle. To begin with, I'll start with redefining the angle. The angle that has been explained is actually this angle A1OA, which is obtained by rotating this initial line segment OA about the point O from the initial axis OX. Now, when you mean rotation, the rotation could be anti-clockwise direction, clockwise direction. The anti-clockwise direction movement is always considered as positive, and the clockwise direction is considered as negative. So the angle described or explained is the angle between the terminal position of this rotating line OA about the initial axis OX in the positive direction, that is anti-clockwise direction. Since this angle is the displacement of OA from the initial axis, it says that we can rotate it further and that thus it moves beyond 90 degree. In fact, it can go beyond 180 degree and further 370 degree to 360 degree. So the angle that we have is not specifically now meant for 0 to 90. It is anything from 0 to 90 to 180 to 270 to 360. If this line rotates further, we find that the angle made by it is more than 360. But it will always be congruent to the angle that is there between 0 to 360. So the first definition that we have is theta. Now what is theta? How do we find theta? Theta is the angle made by the terminal position of the rotating line, that is initial line OA, about the point O in the anti-clockwise direction. So it's angle A1OA. A1OA. The direction of the angle is very clearly mentioned here. Now, in case if we take the direction in the opposite direction, that is its clockwise direction, so it's A085, then the angle measured is minus, it's negative. So the positive angle is when the moment is in the anti-clockwise direction. Negative angle is if it is in the direction of clockwise direction. Now the next element that we have is the peak, that is the length of the perpendicular. Now what is that length of the perpendicular? Now if the line OA is rotated, the line OA is rotated about the point O, it takes the new position A1. To form that right angle triangle that we see here, we need to drop a perpendicular from A1 onto the initial axis, that is OX. So that is the quantity P we have. So the P that we have defined is nothing but the distance of A1 from the initial axis OX, and distance between a point and the line is obtained by dropping a perpendicular from the point onto the line. We see that in this position a perpendicular is dropped from A2 onto the initial axis. So this length is defined as the perpendicular length. For this angle, this is the position of OA, that is OA3. OA3 means the angle described by OA when it is rotated is theta 3. It's from OX. So we drop a perpendicular from A3 onto the initial axis. So this happens to be the perpendicular. Likewise, for this position, the position is for angle theta 4, that's from OX to this line segment OA4. It's theta 4, which happens to be in the third quadrant. That is greater than 180 degree, less than 270 degree. For P, drop a perpendicular from A4 onto the initial axis. So this length is P4. We can take up one more situation where the angle mentioned is in the fourth quadrant. This is in the fourth quadrant. This is in the anti-clockwise direction, fourth quadrant. So again, the final position A5, from here you drop a perpendicular onto the initial axis. So this happens to be the perpendicular. Now the last quantity, that is the base. The base part, that is this length. This is nothing but the distance between O and this point. This point is known as the foot of the perpendicular. So the B1 that we have is distance between O and B1, that the perpendicular dropped from A onto the x-axis. For this position, perpendicular dropped from A2 happens to be this. So B2 happens to be the foot of the perpendicular. So this length OB2 is B2. Likewise, for this position, the perpendicular dropped from this is on X is this length. So this is the base. So what we have seen is the base, perpendicular and all is defined in terms of the Cartesian system, which says that it can be positive, it can be negative. It can be negative, can be positive. Now what about this quantity OA? When you observe it carefully, you'll find that OA is nothing but the radius of the circle. OA is the radius of the circle whose center is O. So that's the reason why we term this as R rather than hypotenuse. So this length is termed as R. That's R. So thus we find that we have redefined the three elements, that is the perpendicular, the base and the radius with respect to the theta. Now let us discuss about the ratios in particular for different angles in different situations. So first situation I have taken is when it's greater than 90 degree but less than 180 degree. So this is the angle described by OA, which is greater than 90 degree, less than 180 degree. So the angle that has been taken up is this angle theta 1, which is nothing but XOA1. For the angle XOA1, we'll be finding the ratio of this quantity that's known as the length of the perpendicular from A1 with respect to the radius of that circle, or foot of the perpendicular's distance from the origin with respect to the radius or between these two. In particular, I am discussing only two of the quantities, that is sine ratio and the cosine ratio, because what we find is we can get the rest of the four in terms of this. So we'll focus only on these two. So in this situation, what we find is the sine ratio, the definition of ratio does not change. It is perpendicular upon the hypotenuse. So this quantity that we have is A1, B1 is measured in the positive y-axis direction, so which is P upon R. The cosine ratio, which is OB1, which is measured on the negative x-axis, so we take it as minus B upon R. So here we find that the ratios can be positive or negative depending upon the measure of the angle. So when you find that the angle's measure is in the second quadrant, this is the second quadrant, in that quadrant we find that the sine ratio is positive, cosine ratio is negative. Now if you see the rest of the four quantities, as you know that tan ratio is sine upon cos. So sine upon cos says that the ratio is negative. Obviously, the reciprocal of this cot theta will also be negative. The reciprocal of sine cosec theta will be positive. Reciprocal of cos sec theta will be negative. So what we find is, if the measure of the angle is such that it lies in the second quadrant, then two ratios are positive, the rest four are negative. Let's take up the next situation. The next situation is when the measure of the angle is greater than 180 degree but less than 270 degree. Now greater than 180, less than 270, that's the third quadrant. So in this, the length of the perpendicular is this, which is measured in the negative y-axis direction, which is minus P upon R. Distance of the foot of the perpendicular, it is B2 to O, which is also negative on the negative x-axis. So that quantity is also negative. So because of this, both sine ratio and cosine ratio happens to be negative. So therefore, the tan ratio will be positive. So again you see that in the third quadrant, the tan ratio is positive, hence its reciprocal, that is cotangent, will also be positive. The remaining four will be negative. Now for the angle in the fourth quadrant, sine ratio measured in the negative y-axis direction, cosine ratio measured in terms of positive x-axis direction. So the sine ratio is negative, cosine ratio is positive. So in the fourth quadrant, it's the cosine ratio that's positive and hence secant. So what we conclude from here is, if the angles are in any one of these quadrant, two of the ratios are positive, the rest four will be negative, except in the first quadrant where all the ratios are positive. So that's the first information that we have. Now to find the ratios for the angles, we take the help of the angles which we are aware of.